Hey guys, so next is r cos theta plus minus alpha and r sin theta plus minus alpha forms. You might have come across with a situation with a trigonometric function expression, anything you can say, which involves both sin theta and cos theta terms, right? One way is to, means what we have to do is we just have to remove one different trigonometric function and replace this by a single trigonometric function. For example, what I mean to say is you have, let us say, a cos theta plus b sin theta. So what we have to do here is, since as you can see these are two different types of trigonometric ratios, sin theta and cos theta, so we have to remove one trigonometric ratio. Okay, there may be different ways to remove this. The most obvious way is to represent sin theta in terms of cos theta using the identity, which is sin square theta plus cos square theta is equal to 1, right? So I can replace this sin theta with cos theta as that this is a cos theta plus b times sin theta will be cos 1 minus cos square theta under root. Okay, 1 minus cos square theta under root. Sin theta is this. Though you have removed one trigonometric ratios, your reduced expression, trigonometric expression, contains only a single trigonometric ratio, that is cos theta. But again, since under root is involved in this expression, it becomes a tedious job. If under root is involved in any expression, whether it is trigonometric or algebraic, it still remains a very complex process. So how to remove this means, I would say that this won't be a preferable method to remove this sin theta and then arranging some or getting an expression, right, final expression. So what we have to do, let us remove this. Before arriving these final forms are cos theta plus minus alpha forms or sin theta plus minus alpha forms, let us first understand how we can generate these two different types of function, or what are the practical situations where we arrive at these types of expressions which have two different types of sinusoidal functions. Both the functions, I would say that these are sinusoidal because the shape of these two curves are both of the sine curve, right? It is just there is a difference of pi by 2 angle between cos theta and sin theta. We said that there is a phase difference between sin theta and cos theta. This term phase, it is associated with some, means it is an enduring term. Okay, so I was talking about what are the practical situations. So all these electromagnetic radiations that you can say the communication that is happening in mobile, so all the mobile communication, the signals that we are generating and receiving, transmitting or receiving in this mobile network, these are represented using electromagnetic waves, or not represented, these are actually electromagnetic waves, and these electromagnetic waves mathematically are represented by sinusoidal curves or just sin theta and cos theta. So for example, from one direction one signal is coming and you are representing that signal using a cos theta, right? It is a sinusoidal wave, so it is coming like this. And from another direction, let us say there is another signal coming which is represented by b sin theta, right? So practically what is happening is that the resultant wave is flowing from the transmitter to the receiver, right? It is not that a cos theta is coming from this direction, b sin theta is coming from this direction, and both the signal are coming to your mobile phone. No, it is not the case. I'm just talking in very crude sense. Actually there is more maths involved in this, but just to make you understand the process, or you can say the main logic or the motive behind doing this a cos theta plus b sin theta into r cos theta and sin theta form. Okay, so I was saying that since these two different types of functions are coming, different types of sinusoidal waves are coming, the resultant actually is flowing from the transmitter to receiver, right? So we have to represent a single sinusoidal curve which is addition of two different types of sinusoidal curve, right? It is just like 2 plus 3 is 5. So 2 is a natural number, 3 is a natural number. So if we add 2 plus 3, again you will get a natural number, right, which is 5, and totally different from both the initial numbers. So Here also the resultant signal will be different from a cos theta and sin theta, but yes, it will follow one property, that it will again be a sinusoidal curve, right? And there is obviously a phase difference between the resultant and the initial two signals. Okay, same process occurs in the three-phase supply that we are getting in our homes, right? Three-phase supply means all these, as you know, that in our house, in our homes, alternating current we are receiving from the transmitter, from the transformer. So all these alternating currents, alternating voltage, these are represented using sinusoidal curve, or mathematically by sin theta and cos theta, right? So there are various processes, practical situations which involves these types of expressions. Okay, so basic motive here is we have to eliminate this sin theta and cos theta and apply a method so that we can have a final expression which should be either sin or in cos, right? And obviously there must be some magnitude of this. Okay, as here in the initial this first one you have a magnitude of A, here we have a magnitude of B, right? So what will be the resultant magnitude of that resultant signal? Okay, so what is the method? Method is that you first multiply and divide by A square plus B square under root. So what you do is you multiply this expression with A square plus B square under root and divide by A square plus B square under root. Okay, here it is cos theta. This A cos theta was as it is from the first expression, and what I have done is multiply and divide by A square plus B square and moving that inside the bracket. Okay, so this will become B upon A square plus B square cos theta, not cos theta, sin theta. Okay, fine. So A square plus B square under root, we have multiplied and divide and moving the denominator part inside the bracket. Okay, now I know that I have a formula of sin A plus B which involves both sin A and cos A, sin B and cos B, right? It is sin A cos B and it is sin B cos A. Okay, so cos A and cos B, these are interchange in this A and B, all right? So I have to represent this RHS back into LHS, right? So consider this, that this is one, you can say, trigonometric ratio of some angle alpha, right? So you think of a triangle, right? Consider this angle as alpha. Consider the opposite as A and base as B. So hypotenuse is A square plus B square under root. Okay. So these trigonometric ratios, if you define sine alpha, you will get A upon A square plus B square under root. I think there is no harm in doing this, right? So this expression A upon A square plus B square under root, I will consider this as a part of a right angled triangle whose opposite is A and base is B. So in terms of A, as these A, B, I am calling these as the sides of a triangle. So whenever there is a triangle, trigonometry can be applied. If there is a triangle, there is an angle, and that angle is alpha, right? And we can represent these sides with using trigonometric ratios, right? So it is just pure math. So A square plus B square under root, I can write this A upon A square plus B square just as sine alpha, right? So using the different color, I am writing this as sine alpha, okay, and cos theta as it is, plus B upon A square plus B square under root from this triangle will be the cosine of angle alpha. So this is cos alpha sine theta, okay. Now the moment I see sine alpha cos theta plus cos alpha sine theta, right, I can apply the formula of sine theta plus alpha. So it is a square plus b square under root. Inside the bracket, I may use the square bracket. I can write this as sine, or not a square bracket. It is sine theta plus alpha. Okay, now this is the resultant expression that I have represented a cos theta plus b sine theta. Right, these two were the different trigonometric functions into a single trigonometric function, which is just sine. So dealing with two different trigonometric function and dealing with just a single sine theta plus alpha, right, this is more easier, right? And I would say that cos alpha value is b upon a square plus b square under root, and value of r will be a square plus b square under root. Okay, so I can write this expression as r sine theta plus alpha. Okay, now let us look back at the original expression that it was plus here. So if I have to convert this into sine form, right, not cosine form, sine form, then there is a plus here. So you remember the formula of sine a plus b, right? There is always a plus if it is plus here, right? So if this is a cos theta plus b sine theta, so obviously you have to convert this, and you are converting in sine form, then it will be of the form sine theta plus alpha, right? We can also convert this into cosine form, but in that case, if this is plus here, so I have to use cos theta minus alpha form, because in cos theta minus alpha, in the RHS, it will be cos theta cos alpha plus sine theta sine alpha. You can also represent this a cos theta plus b sine theta in cosine form also, right? But in that case, that will be r cos of theta minus alpha, right? And the value of alpha you will obtain by dividing b by a. Okay, as sine alpha is a upon a square plus b square, cos alpha is b upon a square plus b square. So if you divide if you divide sine alpha with cos alpha, you will get a upon b, which is nothing but tan alpha, okay, equal to a upon b. That means alpha here will be tan inverse a upon b, and alpha you will include as the principal value. Okay, principal value means either between minus pi by 2 to plus pi by 2. Okay, fine. Tan inverse a by b. Okay, we will do couple of questions, then things will get more clearer, right? So just look at this once again, how we have done this, right? It is just a matter of step that whatever the expression is given, you just square the coefficient of cos theta and sine theta, add those squares, and then make the under root. That will be the value of r. And see the question, if it is asking in terms of sine theta plus alpha, then there has to be plus. If it is asking for cos theta plus alpha, then there has to be minus. We will look into this when we will do some questions.